So I wanted to make one more video talking about reactionary forces, talking about two more types of reactionary forces, and that's compression and tension. And just like how X and Y have positive and negatives, X is left and right, left is negative, obviously, right is positive, and then Y is up and down is negative, and up is obviously positive. Compression and tension also have positive and negatives as well, and they are themselves positive and negative. So we'll talk about compression first. Compression, which by the way is negative. And then of course its sort of counter force, or its opposite force, tension, or in some cases it's even the reactionary force to the other. Tension, and I'll go ahead and tab this out, is always positive. And let's actually write out the word positive correctly. There we go. Let's go ahead and label compression as force of C, and let's label tension as force of T. And let's talk about this. Let's do an example. Let's say we have this big balloon. Let's say we've got some big balloon here. And that balloon looks way better. And let's go ahead and label this as a balloon with 50 pounds of compressed air. So 50 pounds of compressed air. Let's write with 50 pounds of compressed air. Let's move this up a little bit. Okay, so then we have our compression force on the inside. And it is sort of pushing outward on the balloon. We draw it in all directions because it's pushing in all directions. And the only thing that's keeping it from popping is the tension of the balloon itself. We've got all these arrows fighting back, and they are our force of tension. And they're all coming around as well. And if our compression force equals 50 pounds, then our tension force, assuming it's not breaking, also has to equal 50 pounds. Because if it's all holding in place, then the sum of all forces has to equal, well, in this case, it would equal our FC plus our FT, our force compression, plus our force tension. Which in this case, well, in any case where it's not breaking, it's equal to 0. And if the compression got smaller, then the tension would get smaller as well, and it would still equal 0. And of course, as it grows, so will, of course, the tension. So let's write that out. So as let's make this a little bit wider, but let's say as compression grows, so will the tension of the balloon itself. So will the tension of the balloon. And as long as that's happening, we can say the sum of all forces equals 0, as long as the tension grows to meet the compression of the balloon. Excuse me, balloon. But then we can say this is true until it reaches a breaking point. And at that point, we will know that the sum of all forces does not equal 0.